Welcome to another episode of Beta Talk. This season is being sponsored by Primary Pro, which is the professional pipe lagging kit. Please check them out on their website. Lots of the great engineers I know are using it. Now, today I'm joined by Shreyas Sudhakar. He'll correct me if I've got that right. Who's out in that lovely place called America. He's out in California. He does heat pump installations out in America, and I thought, well, I'll bring him on and see what sort of stuff, exciting stuff, is going on in that wonderful place across the Atlantic. Shaz, wonderful to have you on the show. I don't know if you know, but I've spent quite a bit of time in America myself, but that was on the East Coast, so that was sort of
Okay.
mainly in Brooklyn and New York, and obviously I went up to some of the New England states and. Where I grew up in England, in Norfolk, it's very associated with America. So it's where Abraham Lincoln's great grandfather came from, about
Really?
2 miles from where I grew up. And Thomas Paine was about 5 miles down the road, who wrote the Age of Reason and the Rights of Man. So I read them books when I was in America. Um, so I've always loved America. I did my apprenticeship on an American airbase in the UK, and
Very cool.
so yeah, it's a country that fascinates me, and of course your heating systems fascinate me, and that's what I've brought you on the show for. So that before you sort of talk about heat pumps, you come from a really interesting background because you've been involved in some very cutting edge research around rockets and space technology, haven't you?
Yeah. I kind of stumbled into heat pumps in the HVAC industry, but my background is a mechanical engineer. I spent quite a while in the aerospace industry, working on rocket propulsion. So, pretty much everything from on the initial concept sketches on paper to designing all the parts, putting them on the test stand, test firing them, dealing with the engines after they explode, installing them on the rockets. I've done it all, so quite a lot of fun doing that.
Well, as my eldest cousin used to say, he used to say, heating isn't rocket science; it's far more complex. And as you would know better than most, thermodynamic systems are involved in sort of rocket propulsion technology, aren't they? So how did you get involved in heat pumps? What made you want to sort of
Yeah,
get?
it's I mean, I think that's a great segue because I didn't know what heat pumps were until one of my friends brought them up. He had a background in solar and renewables, and he kept talking about heat pumps, and he's like, I'm really excited about this technology. It's super cool. It works like magic, 400% efficient. And I kind of brushed him off. It took me a little while until I actually dug into it, but when I did, I went through this old research paper from the 1970s that was like computer modeling of the refrigeration cycle. And it was just all of these diagrams and pressure and temperature curves and all of that. And what I found, yeah, it's like just like you said, it's all thermodynamics. It's kind of the same stuff, like a lot of fluids, piping, heat exchangers, heat transfer, like all of the fundamentals are pretty much the same as what I'd been working on in rockets. And so it's it's cool when you understand the first principles of something like pretty immediately. And like, but I think you're also right. Like heat pumps are actually probably 100 times harder than than rockets because you only have to you only have to make a handful of rockets work for a very short amount of time. But like with a heat pump, you have to get uh, some guy 1,000 miles from the factory where it was built to put it in right and get it to work for 20 years. And the whole thing costs about $15,000. A single like part of my rocket engine was like $500,000. Like, so it's just a whole different ballgame.
And so you literally, I mean, from your sort of LinkedIn profile, you started up a national company, I believe, and well, I'll ask you in a minute if that's still how your business sort of. And then did you sort of go out on your own or with other people and actually get involved in installation work?
Yeah, so the very first heat pump I installed was with me and a couple friends. It was in my father-in-law's house, and we just he knew that if we did a bad job, we would come back and fix it, or else I'd be disowned from the family. So and so that's the first time I did it, and we watched some YouTube videos, kind of taught myself how to install a heat pump, how to how to make flare connections, how to pull a vacuum on refrigerant lines, bought all the tools on online. And so that was my start. And then yeah, I my last company, we raised some venture funding. We were building a national heat pump installer across the US. That was a couple years ago. That company is still going, but I've since branched off and started a new company called Vayu.
Okay, tell us about that. So, what is that? Just an installation company based where you are? So,
Yeah, so Vayu is a heat pump installation company in California. Right now, we're operating in the San Francisco Bay Area, and then we're going to be expanding to Los Angeles later this year. But yeah, regional installer of heat pumps. We partner with some really great technicians that do the work, and I think what I've found through my HVAC career is there are a lot of exceptional heat pump installers out there. But a lot of the very best technicians run little one man in a van type shops, and so they're doing everything. They're going out during the day and installing. When they get home at night, they're writing up the invoices. They're doing all the sizing calculations when they can. They're just really swamped, and so my company partners with a lot of people like that. They do what they love to do, which is the installation work. I handle a lot of the engineering, the sizing, the permits, the handling the customers, and so it's a bit of a win-win for both of us. The customer gets a really great experience out of it, and it's been working really well.
oh, that's a good idea. So you sort of like handle back office type things, and yeah, you're right. Because obviously, natural engineers aren't really good at that sort of stuff, are they?
Yeah, it's like it takes a lot to run a successful HVAC company, right? Like you need to have customer service, you need to be able to advertise, you need to do a lot of paperwork. You have to call the permit office, and then there's also just the technical sizing stuff, right? Like what size system do I need for this house? Like how many square feet is it? What's the insulation like? There's a lot of work that goes on behind the scenes, and if like a homeowner just sees like the 1 or 2 days when the technician is in their house doing the work, but for those 1 or 2 days, there's probably a week or two of like behind the scenes preparation to get that system ready, right?
Yeah. Now, I've got a question. So I've always been a bit curious about what goes on in America, and like I said earlier, I've got this massive love of America because I've worked around a lot of Americans in my life, and when it comes to music, you guys are great. I mean, you're not as great as the UK. We've still got the best bands, but you're easily second. When it
Second
comes
place.
to when it comes to sport, you are the best. I mean, my youngest, no, my eldest nephew's 17. He's one of the quickest in the country cross country, and he's just got a scholarship to go to America for 4 years with one of the unis. So,
Love it.
and he will get his whole 4 years education paid for, his accommodation paid for, his sports coaching paid, everything's done. Now, in this, that doesn't happen in this country. He'd have to pay for that all himself. So, when it comes to looking after people that are good at stuff, second to none. You guys are second to none. You're really good at that. Now, what I find very strange though, you guys have had heat pump systems for a long time. So, a long time. So, when I explain to people what a heat pump system is, the simplest way I say it's look, it's just something moving energy from an evaporator to a condenser. That's it, via vapor
Right.
compression. It's just moving something energy from an evaporator to a condenser. There's millions of it over where you guys live because you have what you call AC systems. Now, I'd call them comfort cooling systems, but you call them
Right.
AC systems. And all they're doing is just moving heat one way. They move it out of the home. Okay. And that's what we call cooling. And whereas in this country, we've been putting systems in for about 4 decades that will move it out of the building, cooling, and then they'll move it back into the building in winter. That's heating. You guys don't do that. You'll do it like where you'll have a heat pump system to move the heat out, and then you'll bolt on the furnace onto the same sort of ductwork that then pushes heat in. And the only analogy I can think of, it's like having a really efficient electric train be able to go one direction from point A to point B, and then to get back from point B to A, it switches back to cold and steam. I've never understood why. I mean, because bi-directional heat pumps have been around decades. Well, I could never understand why America never switched. So obviously you put in bi-directional heat pumps,
Right.
which do both, don't you? So I mean, why do you think that is going on in them? Or because there is, as you and I know, when I look at people on LinkedIn, you're doing really really good work. You understand the science, you understand that they can do both things, but there's still a bit of a pushback. There are people still thinking, no, no, you have to have a furnace. It can't heat the property, and I'm thinking, well, it's really interesting why people would think that.
Yeah, it's quite fascinating. And like you said, I mean, I think like Carrier invented the air conditioner in the US in like the early 1900s. So we have a lot of legacy, like a a big fraction of homes in the US already have AC, but like you said, it's one way AC. It'll only cool and then we tie the furnace to it. And I think there's a lot of history with that. Like historically, natural gas in the US has been very cheap. And so it's very easy to pipe gas into a house and burn it and generate heat. And so that's just kind of what's been done. I mean, in the Northeast, there's a lot of fuel oil, and some people have propane tanks. But whatever the case, we really love burning fossils to generate heat. I think there is some history around um, early generations of two-way heat pumps that didn't work well in the colder climates. And so I think there are some technicians who did work with those systems back in the day that got burned by them and have bad taste in their mouth. But as you're well aware, like cold climate heat pumps are really good nowadays. You can heat even in like the cold Nordic climates, like
Yeah.
people are heating their homes entirely with electricity perfectly fine.
Mm.
And then there's also just like the skill level to like swap a gas furnace is very low. Like you have like especially like the older lower efficiency gas furnaces, you basically connect the tube to it. You connect a little sheet metal tape, like it like a guy can go in and out in 3 hours and have a furnace changed out. And so I think there's just a lot of market inertia for this is how we've done it. A lot of the products. I was talking with a friend that said like in a lot of regions around the country they don't even stock two-way heat pump systems on the shelves. Like the distributors only carry the one-way stuff. So there's no like technological reason for them to not exist, but it's purely like a cultural and like a market inertia type thing from what I've seen.
Yeah, it's super super strange. And of course, I suppose for the listeners that don't know too much about American heating systems, yeah, not so much in the New England states. They sort of sometimes have what we have. They have sort of radiators, wet systems, but most states will have ductwork. So
Right.
you're either blowing hot air down that ductwork, blowing cool air, blow whatever you want down the ductwork. But you basically build houses, don't you, with ducting? which is
Exactly.
which is a different skill together because that has to be sized. It doesn't tend to go on much in domestic properties over here. In commercial, it does. I mean, there's ducting everywhere commercially in this country, everywhere. Same as it would be in your country. But yeah, in your homes, you build them, don't you, with this ducting already in, don't you?
Yeah, and so like pretty much all new construction homes have ductwork in by default. And actually what I found is that a lot of older homes that were originally built without ductwork got retrofitted with ductwork in the 50s or 60s. And so as central forced air systems became more prevalent, like homes that didn't have them got them. So by and large, the majority of homes in the United States, for better or worse, are heated and cooled with ducted systems. And I think there's some psychology around it too, as a lot of people are not used to having heating equipment visible in their home. It's like something invisible that you don't think about. Your furnace is hidden in a utility closet or in an attic or a crawl space, and so you just don't see it. You forget about it. Your only interaction with your heating and cooling is that thermostat on the wall.
Do the same people that work on the refrigeration side of things, and you guys call them technicians. We're going to talk about uh, that in a minute. But do the same people work on the ducting, or do you have different people that do the ducting, different people that do the sort of the refrigeration side of things?
Yeah, right now for the most part it's all in one. So,
Right.
it like when we talk about an HVAC technician in the US, it's they're doing sheet metal work, they're doing plumbing, they're doing electrical, they're doing refrigeration, like all of these trades in one. So it's a lot, and it brings up some like skilled labor challenges because it's hard enough to train someone on just one of those areas, but to have someone be competent at all of those different areas is tough.
Yeah. And I mentioned this word technician, so I don't know if you know. So in this country, we've been using this word installer.
Okay.
I'm going to say for about 15 years, 20 years. I've grown up in the industry, so the word installer is relatively new. So
Hmm.
back in the day, most people that were doing plumbing and heating would have been employed. So they would have been employed by the local regional gas boards, councils, and you would have had engineers and designers that were designing stuff. And then
Right.
you would had fitters that went it out and fitted the stuff. And then you would have commissioning engineers and maintenance engineers. And this word installer became a thing. I don't like the word because I think it's dumbed down what some people can actually do. I've got friends that
Hmm.
can go in, commission a system brilliantly. Yes, they can install a system brilliantly. They can design the system brilliantly. I call them engineers. They haven't got degrees,
Right.
and some elitists in this country say you have to have the degrees to call yourself an engineer. And I'm qualified enough to say sod you. If they want, if I think
I'm
they're an
with you there.
engineer, they're an engineer. But you guys use this word technicians, don't you? And because so I think you do have a difference between technicians and engineers, don't you? I think if I'm right.
Yeah, so I think you bring up a good point. So generally, there's kind of two buckets of technicians in the U.S. There's install technicians, and then there's service technicians. And people can kind of float between those two things, but generally, what it looks like is the install guys have gotten really good at I'm going into a home, I'm ripping out the old system, I'm putting in a new system. I'm gonna work through that as quickly as possible. I do all the heavy lifting. I do the carpentry work to like fit the new equipment in, like kind of that side of things. And then the service technicians kind of cover, um, oh, the system in your house isn't working right. Let me go through the troubleshooting. I'll look at the schematics for the circuit board. I'll figure out where like the burnt out chip is, whatever. Like those are the service technicians. And of course, like I think the best people have both of those skill sets, and they're able to both install and troubleshoot. But that seems to be how the labor is split up. But interestingly, we don't actually have much of the engineers in the US, at least the way the market has built out right now. What we have right now are estimators, which are really dolled up salespeople. And so the estimators are the guys that come into your home. They bring their iPad and they say, "Oh, this is what you need for your house." They make a report, they write you up, and then some guy comes in with the equipment and figures out how to put it in a few weeks later. And so I think that's actually, in my opinion, a big gap in the American market right now is like there's not necessarily people with the technical competence that are going in and really sizing the house, figuring out how much like heat is coming in through the windows, how much we're losing through the floors, how big the system really needs to be. And that has been fine historically because you can oversize the hell out of a furnace. Like most houses have a furnace that's probably 3 or 4 times bigger than it ever needs to be. And it's okay because it'll just kick on for a few minutes, get the house really warm, turn off, and then keep doing that over and over. But with a heat pump, it matters a lot more that you size it right, right?
Well, I mean, you could say that about American cars. They're about 3, 4 times bigger than what they need to be. I mean, the amount of metal that goes into some of the cars over there, and you think, do you really need that amount of metal? Now, I imagine you've got that engineering mindset, though. Obviously, yes, I was going to say because I mean, I imagine you can look at PT charts or enthalpy diagrams and kind of get them. Whereas I suppose
Yeah.
a lot of your technicians, and it's not being dismissive to them, wouldn't understand sort of them sort of diagrams. But I imagine you do because you come from, I am presuming, a mathematical and physics background. So that's really
Yeah.
interesting. That's really
Yeah,
interesting.
exactly.
Well, I mean, and like what you said about sales and marketing. I mean, yes, let's face it. Another fantastic thing. They've got the best marketing and salespeople in the world. They kind of invented that. Arguably, that's why this planet's in a bit of a mess because we've all been convinced to buy stuff that we don't need. Uh, so yeah, you've definitely got the best marketing people. So
Yeah,
that's
yeah,
interesting because yes, so you've got a lack of sort of these people that can sort of now in our country that's exactly the same. But what we're finding is some of the engineers. I interviewed one recently that they're loving this design. What they're loving actually now is their industry's being seen as quite a technical industry. It wasn't for so long,
right.
it was just putting stuff in, putting boilers in. But now we're all talking about transition and decarbonisation. People are starting to realise, the government are realising that this is a real scientific kind of trade.
Totally.
And so you've got some engineers that have lapped that up. They're getting in, they're getting involved with chatting to each other, learning from each other, which I'm a big sort of advocate of. And they're becoming very they're super at like designing and using the calculations, and I think they're really enjoying it. And I think they're also really enjoying the fact that they're now being seen as quite elite tradespeople, compared to other types of tradespeople, not being
Totally.
dismissive to them. But yeah, so that's interesting how that sort of market is growing. And I presume that there must be some people in America that have got well, like you did, you got an interest in this because it is quite interesting. This all sort of sciencey stuff around vapor compression, isn't it? It's quite a sciencey type thing.
Yeah, absolutely. And I think I I really agree with you with what you said earlier that like to be a good engineer, you don't necessarily have to have an engineering degree. Like I've worked with a lot of brilliant we would call them technicians, right? But like that they understand the fundamentals, they understand the math, they have the interest and they've taught themselves like how this thing works. And like personally, like I went to school, I got my bachelor's and master's in engineering, right? But I have learned far more by being hands-on, by turning wrenches, by like getting familiar with the equipment um than I did by sitting in a classroom and listening to a lecture. And in fact, I think a lot of the technicians I work with would make far better engineers than a lot of the engineers that I went to school with. So, yeah, I
Yeah.
think there are a lot of brilliant people, and I think there are a lot of opportunities to set these people up into these more design roles as the trade is starting to evolve. I think we're going to have more and more demand. I think a lot of people are recognizing that these aren't just boxes you put in a house. You really have to be mindful about like the commissioning, the selection of the equipment, sizing it appropriately. And I think those are great opportunities for the very best and the very like most interested technicians to kind of grow into these new roles.
Do you see? Is there a lot of young people moving into these roles? Is this something that's sort of promoted within colleges or schools, that sort of
Yeah,
system?
I think we kind of missed a generation in the US. There's I think we've had a lot of push around getting people to go to college. And so a lot of people went to college, a lot of trade programs got pulled out of schools. Like when I was in high school, like the trade program had like been shut down a few years prior, and so that just wasn't something available to me. But there are brilliant programs that are doing this training work. I think people are realizing that we made a mistake here. Like the trades are an incredible career path. They're really well suited to a certain type of person, and like we need to provide this career path to get people in. And so I actually have been working with a program here in California that helps people like in like a rougher part of town change their career and move into HVAC and become heat pump installers. And it's really cool to see that sort of program coming around. And at the same time, I think I've found that some of the best early technicians I've worked with have no formal education. They're just like a friend of someone who was in the trade or a cousin or something. They just got roped in by their relative or their friend, and then they learned on the job and they just asked the right questions and got
Yeah.
into it, right?
Yeah, yeah, yeah. Oh, that's fantastic. I mean, because I imagine sort of the part of the world you're in. I mean, this is an assumption, but I suppose a lot of young people want to get into tech and computers and software because obviously that's your part of the world is very, very famous for that, isn't it?
Yeah, I mean, like California, like San Francisco is like the center of Silicon Valley and all of the tech scene. But I think that just does a disservice to the diversity of people here too, right? That is definitely a big part of the community. But there are also a lot of people that work in retail and work in food service and like work in the trades and all of that. And so like there while there is a lot of like that shininess and that's maybe what we pay attention to, there are a lot of like exceptional people that are working on this stuff too.
Now, you mentioned a manufacturer. You mentioned the really, really famous one, Carrier, because obviously, yeah, Carrier was sort of instrumental in inventing a lot of the sort of
Yeah.
this stuff. What do you like to use? I mean, for one question I want to ask is, have you got access to sort of the European or the stuff that the European market is using? Or because obviously, as we know, America have very established brands, whether it's vehicles or
Right.
whatever it is. I mean, are you using, have you got access to a range of manufacturers, or do you tend to use just the US ones?
Yeah, no, I do have access to a range of them, but I think the equipment that we work with is probably quite a bit different than the equipment you're working with. Especially, I guess a few key differences. Like R290 propane refrigerant is restricted here in the U.S., and so there's a lot of pushback around flammability, which personally I think is a lot about nothing. So we don't see those systems on the market. The monoblock air to water systems, which I know are pretty popular for you guys, we're really don't see those on the market either. Pretty much everything is air to air, and so like and so the systems are different, but we do see a big variety. There are, of course, the American manufacturers, so like the Carrier, the Goodman, Bryant, like those brands definitely exist. But we also see Mitsubishi and Daikin and those Japanese brands, as well as like the Chinese brands like Gree and Midea and all of that. And there's a pretty strong amount of white labeling as well. I don't know if you see that in the UK, but distributors will put their sticker on equipment from China, and they'll provide the support for it too.
Oh, that's that. I mean, that is a huge part of the industry. So yeah, Medea have I never know how to pronounce it. Medea, massive in this. I think someone said they're the OEM for about 15 to 17 manufacturers in this country. I think out in
Right.
Poland they're up to about 29. So you'll often, I mean, even the big well-known brands like Ideal. So Ideal, they're the top boiler seller in this country, gas
Sure.
boiler. They've transitioned into heat pumps, but their heat pumps are made by Fujitsu. Actually,
Hmm.
to be fair, Fujitsu is part of Group Atlantic, I think, and Group Atlantic Ideal are part of Group Atlantic. So you'll often find some of these companies are part of larger groups, and their other heat pump unit is Midea. Bosch, one of their units is Midea. Their other one is Bosch.
Sure.
Baxis is Midea. Yeah, loads and loads of use. I think
Yeah.
Gree, you mentioned Gree. I'm just trying to think if the new Grant is Gree. I mean, the last one was Shofu. So yeah, that goes on. That goes on a lot, uh, which is it's quite super interesting. Actually, I find it interesting anyway. I mean, I get because
Yeah.
I'm a podcast host, so I get followed a lot by the Chinese manufacturers, and
Right.
I think when they first start following, they think I'm some sort of big distributor or something, and they're always trying to sell me a heat pump. But I always then ask them, because they always say, "Oh, we're one of the biggest OEMs in the world," and I'm like, well, "Okay,
Right.
list who the ones you make them for," and of course they won't tell you because they're not supposed to. But I usually end up finding out. But No, that's a really interesting part of the industry, isn't it? 'Cause- So there's a lot of competition, and
Yeah,
I sometimes ask myself, I wonder if that competition is actually beneficial, or because in the UK, I don't know really what it's like in the America. In the UK, we have an extremely overcrowded competitive market. So basically, anyone that makes any heating equipment in Europe is selling in the UK,
sure.
and that has its own that brings its own challenges because everyone's trying to compete for a bit of the market. So a lot of the
Yeah,
marketing messages, I would say, and I have said, and I do argue that aren't quite correct.
yeah.
Whether that will get better with competition, I don't know. And what is it getting competitive out in the States?
Yeah, no, I'm with you. There's a lot of choice, but I think there's also a lot of like dogmatic like behavior from technicians. It's like I'm a train dealer. Train is what I use, and then there's someone else that's like I'm a carrier dealer. Carrier is the best one out there. But like frankly, like looking at this equipment as an engineer, like fundamentally all of it's pretty similar. I think the quality level like I'm seeing it's all pretty consistent. Like even the lowest tier equipment is pretty well built. And so I find that I feel like we should be putting more focus into how the equipment is installed and like how it's taken care of rather than what equipment that we're putting in. But I think it's something that again going back to that sales process, like I think it's used a lot as a sales tool and someone will say, "Oh, we only carry carrier because train is bad," and then the other person will say, "Oh, we only carry train because carrier is bad," and then the customer is just left in the lurch in between. They don't know any better, right? And so
Yeah. So, and what about technical support? So in this country, what one of the reasons why, so it's not the customer that tends to choose the equipment. It'll be the installation engineer
right.
that's choosing the equipment, and um, that they'll usually choose equipment based around whether they've got good technical service support and
Yeah.
pre-sale support, and that's usually comes down to a human factor. So if their local technical rep in the particular area they live, they get on well with, is nice, and is always there to support them if they need it,
Yeah.
that tends to be the manufacturer they will use, and the manufacturers know this. So if they spot a technical representative doing really, really well and has got sort of good relationships with engineers, you'll
Yeah.
get another manufacturer try and nick them because what happens is the engineers move over to that other manufacturer because it's
Right.
not so much the
Right.
manufacturer that it's not so much the equipment, it's the person. Um, so yeah, it tends to be very much around technical support, pre-sales support. I mean, is that the same sort of thing going on over in the States?
Yeah, for sure. It's definitely a big dynamic. Like I think a lot of the technical support in the US is actually held at the distributor level. And so the distributors are the ones that kind of do the trainings with the technicians. They're the ones that hand out their business card with their phone number and say, call me anytime with your questions and all of that. And so when I'm, say, working with Mitsubishi, I'm not working with someone at Mitsubishi, the company. I'm working with someone at like CFM, which is the local distributor, and they're the one that has been trained up on the equipment. And so yeah, I think you're definitely right that like that plays a big role. And it's not just the sales support, but it's also just availability of equipment. Like we've been going through a refrigerant transition over the past few months. So everything in the US up until this year was pretty much R410A.
Yeah,
Now we're switching to R32 and R454B.
yeah.
And there's just a lot of supply constraints. And sometimes it's as simple as where can I get equipment from? And you might just have to use use the brand that you can find.
Yeah, yeah, that's interesting. Do you have like big shows? So in this country, our sort of largest trade show is the installer show, and there's the big German one coming up imminently, which is called
Yeah.
Ish, which is huge, um, biggest in Europe. I mean, it might even be the biggest in the world. I'm not sure. But do you guys? I assume you because you're well famous for for trade fairs, aren't you? Especially in Vegas. Do you have any of the big sort of trade fairs going on?
Yeah, the biggest one is called AHR, and that one's held annually. I went to it a couple years ago in Chicago. They move it around the country every year, and so that is that is it's both a trade show and a technical show. And so AHR is the trade show side of things. All the manufacturers come out with their newest equipment. The tool makers are there to show off their stuff. But then adjoining it is the ASHRAE conference. And so that's like the American Society of Heating and Refrigeration Engineers. And so that's far more technical. You get all of the college professors and the academics like showcasing kind of like the very like cutting edge research in refrigeration tech.
Yeah, they're that's world renowned, Ashray, isn't it? And you get some very,
Yeah.
very, 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 very clever people involved in that. Um, yeah, that's it. So your trade shows are quite interesting, I imagine, and I imagine you got some great salespeople there. Um, when it comes to sizing, just I'd like you to sort of help because when we size equipment, we size it differently to you, as you probably know.
Sure.
You size it in tons, and I didn't know whether
Yep.
you'd be able to explain to my listeners. So just in case they're ever reading a LinkedIn post and it says, we put in a 3-ton system, they understand what that's all about.
Yeah, I might be butchering this a little bit, but the sizing for tons goes back historically to the I think it's the amount of energy needed to melt a ton of ice. And so this goes back to back in the day when houses were literally cooled with blocks of ice that were put in just like a big freezer. And so 1 ton is 12,000 BTU per hour. And of course, we do everything in incomprehensible units. So I could not tell you how many kilowatts that is off the top of my head. But so that
Yeah,
that's
it's interesting how you use that British thermal units, well, I quite like the fact you're using sort of a British thing. Uh,
but you don't even use them and you're in Britain, right?
no, we do. Well, we used to. We used to,
Okay.
and then we switched to um, kilowatt hours. And I mean, if you look at interestingly, if you look at old boilers, the boiler plate would say BTU hours, and it would also sometimes say joules per second as well.
Hmm.
It sometimes do that as well. Because interestingly, I tend to use joules a lot now because I think it helps. What I'm finding with some engineers is, and it's not their fault, bless them. Engineers get trained to safely install gas equipment
Sure.
for obvious reasons, and they're really really good at it. If you've got a boiler that's broke down, it's really cold, it's late at night. Let's say you've got young kids, you want someone to be able to come in and be competent enough to get that boiler working again. And the people that can do
Right.
that are incredible because we've got a lot of makes and models out there now in this country. So anyone that can come in, recognise the make and model, and get that going is brilliant. Because you will have some people come in and think, "Oh, hello, you'll need a new boiler." That's because they're trying to sell a new boiler. Well, that's
Sure.
no good to someone that's cold that night. So it's a real great skill. Now, what you tend to find is the majority of engineers won't be able to answer a question like what is a watt. They don't know it's a joule of heat per second. They don't know the science of heat. They're struggling to understand why radiators don't need to be at 80 degrees centigrade, for instance. They really do they do struggle with that. The great things that they can do with getting this stuff to work when it comes to things like well, you're not going to always need hot radiators because the way heat is leaving your home is constantly the speed of that leaving your home is constantly changing because the temperature outside constantly changes. So it's little things like that, and that's where I come in and try and help them. And just little, you don't need to send them on a course to do that. You're just getting them sort of interested in what that sort of science is all about. But yeah, so we do use kilowatts. But yeah, if you ask most technical directors in this country what is a watt, they probably would be able to answer it. So, which is always interesting to me.
Yeah.
Um, the sort of transition that we're all in. You're getting people fighting back against it in this country. Are people fighting back against it in your country?
Yeah, it's unfortunately heat pumps have kind of become politicized. And so there's definitely like a factor of that. There were a big chunk of subsidies with the Reduction Act under the previous Biden administration for heat pumps, which was great. But I think because of that now there's some association that like a heat pump is tied with a certain like political view.
Right. Yeah.
And then there's also just like the more the more pragmatic pushbacks too. Like electricity is pretty expensive in the US, and so there are definitely situations where it still is cheaper for you to just heat with gas instead of with a heat pump. There's also the cost differential, like in most places in the US, and most companies position them as like a premium product, even though like the only difference between a heat pump and like the one-way AC, which we have, which are like the trains that can only go in one direction, right? Is a single valve. It's like $100 a part. So like, there's no reason that it needs to be this premium product.
I'm
But
just going to explain that to people because it's making you and I laugh. It literally is just one little component inside, isn't it? So, as people have heard me state right at the beginning, all a heat pump is something moving energy from an evaporator to a condenser. Now, the refrigerant always has to go through the compressor the same way. And
yeah,
it's so if you want, whatever's inside, let's say it's the evapor inside, it's still going to be the same. If no one's running outside and putting it and swapping the things over, no one's going lifting up that thing outside and putting that indoors and the thing that was indoors outside. But you can switch your fan coils around by having a reversing valve, which reverses the refrigerant flow to the evaporating condenser, but it doesn't reverse it. It still has to go through the compressor the same way because that's you can only compress vapor. You can't compress liquid, and it's just like you say, it's $100. Probably not even that in some of the machines.
yeah.
It's a metal component, and it's just that's it. Yes, all right. You control strategy, in the circuit board, but you just think to yourself, you just put it's the same unit, and like I say, my family's been putting in reversible heat pumps for 4 decades. And you think, why aren't the Americans still? What I struggle with is why some of the American refrigeration engineers who are going to be great at what they do really are, and they can work with the equipment and maybe even like you sort of understand the science of it and read the PT diagrams really well. But what aren't they getting? Why do they think it's a different and they have to have that furnace on as well? I just don't understand it. But maybe it's me and I'm missing something. I don't know.
I really struggle with this too because I came into this industry as an outsider, right? And so I haven't grown up in the trade. Like I just come in with some fundamental science understanding. I look at the equipment and I'm with you. It's
Yeah.
baffles me that you would choose not to do this when it is so simple. And like you look at especially the newer ultra low NOx gas furnaces that are going in, they're really complex. Like you have the condensing furnace, you have all of like there's a lot of moving parts. There's a lot of potential failure points. And then you say like, why would I do all of that when I can just have the same heat exchanger that I have in there for cooling anyway, add one valve on the outdoor unit, and it's like a much simpler setup.
Yeah, it's confusing. It really is confusing. And I suppose it's because I suppose it might, like you said, if people have been entrenched in the industry, um, they some of their very very closest friends will be like, let's say, people that sell furnaces, them distribute, and,
Yeah.
so I suppose there's something very psychological about it. I mean, it's also the same with not so much with the ducted systems, but like you say, you go to New England, you've got lots of wet systems, and obviously commercially you'll have lots of wet systems, and the Americans always seem to zone with their circulation pumps. So you can go into a
Yes.
large dwelling, beautiful, lovely large dwelling. I don't know, let's say 6 bedrooms, that kind of thing. And you go down in the basement, and there's about 10 pumps, 10 circulation pumps, and you think, what are they all for? And so, pumps use a lot of energy. Circulation pumps, creating the flow of water around the circuit, use a lot of energy, and I can see ASHRAE engineers, top engineers, looking at me now, thinking, "What's Nathan on about?" But we won't do that. We need one circulation pump to create the fluid, and then we can tell it where to go with
Sure.
actuators or valves. But in
Right.
America, I mean, and I know for a fact because I've been out to Denmark and Grundfos. I mean, Grundfos love the American market because you don't just use one pump, you use loads. I mean, obviously Taco, I think are the biggest probably pump circulator company in the US still. But yeah, I imagine Taco. Well, I know Grundfos love it because here we're just using one pump per property
Right.
usually. But
Yeah.
whereas every zone, you know, not as simple as every bedroom, but nearly every zone has got its own separate circulation pump, and you think to yourself, that's so much energy. And but
Yeah, I think this actually has brought up a few thoughts around your earlier question of like why are people so against heat pumps in the US? And I think another part of it from like a technical installation standpoint is historically a lot of heat pump only air handlers have been 240 volts, and all the wiring in the US is 115 volts. So furnaces are traditionally 115 volt. They've been domestically made, and so uh, that often means you have to run a new electrical circuit from the panel. That's $1,000 or $2,000 of like cost to the customer there, right? Also, if you need backup heat strips, a lot of homes don't have electrical capacity to run like a 60 amp circuit for all of these resistant heat strips, right? So that's another challenge. Another thing that I found this is changing is I think a lot of the Asian manufacturers of heat pumps built the boxes that tie in with the ductwork. A lot of them have been square, and a lot of American furnaces are rectangular. And it doesn't seem like much, but it ends up meaning that you have to do a lot of sheet metal work to get it to fit in the same package. And so this is changing. I think a lot of the manufacturers are taking the field feedback. Now we're getting more 115 volt air handlers. We're getting things that fit in the same package as the old stuff, and so it's a lot more of a straightforward swap. But I think those are definitely also factors that
yeah.
have made the furnaces are easy, right? It's a one-to-one swap. You get something that matches the exact same dimensions. You pull it out, plug it in, you're done.
Who are the main furnace manufacturers? Do you know?
Yeah, so it's like Train,
Yeah.
Carrier, Bryant, Goodman, Lennox. So all of like for the most part, I haven't really seen any overseas furnaces. Like all the furnaces for the most part are
So
domestic made.
the furnaces are the same manufacturers as the AC stuff.
Yes, yes. So,
Mm,
and perhaps that's part of it too.
mm.
Like perhaps those furnace manufacturers have invested a lot in their furnace manufacturing capabilities, and they don't want to give that up quite yet. And so, like ultimately, like you said, like the manufacturers and the distributors control a lot of the emotions of the installers, and so
Yeah.
there's still like I still get a lot of marketing from my distributors talking about their new furnace lineups and all of the furnace and AC matchups and all of that. And so I think in general, like the whole industry is still pushing them. It's not just
Yeah, that's interesting. So you got the same manufacturers making the AC stuff, which is just pulling heat out of the home. You got the same manufacturer making the furnace, and of course they don't want one section of that company just to completely fold because that's going to. And I'm going to take some British license here and say that's absolutely bonkers, and I can get away with that because it was the Brits that invented all this stuff. We invented heat basically. Obviously we had Newcomb engines, and we had the Bolt and Watt engine, and then of course
Yep.
probably my favourite engineer was Richard Trefelick, who the world's first locomotive steam train, 1804 on my birthday, 21st of Feb. So yeah, we gave the world that. So I'm going to take license and say that's a little bit bonkers, and something needs to be sorted out there because it makes no sense. It makes
Yeah.
absolutely no sense. And again, I don't want to be dismissive. I love Americans. I love America, and I don't want to be dismissive to anyone involved in the industry out there. But I do think that's a little bit. I think there's some thinking that needs to go on around that because just
Yeah.
bolt in a heat pump that does both. It moves heat in. It's like that analogy. It's like having a train, electric train going from point A to B, and then when you turn it around, you're going to have cold and steam. Makes no sense. But Yeah, that's really interesting. It's the same manufacturers. Well, it makes you wonder then if there's an outside manufacturer can just come in and say, right, who are all these good engineers in America that are doing it right? Who wants to transition? Let's give them the product, and let's
Yeah.
take on the big American brands. Because America likes competition, it likes market. They are the world's best at that. Let's face it. So that would
Yeah.
probably work.
And
Um,
I think a lot of the Asian manufacturers are doing just that because like for the most part, like most of the HVAC equipment I'm installing is from the Chinese manufacturers and they make a pretty good product. It's at a very competitive price point. Like I cannot I cannot put in a furnace and AC. I cannot get that equipment for the price that I get a heat pump from a Chinese manufacturer. And
yeah,
so for me as a business, like it makes a lot of sense for me to put in these really good inverter heat pumps from the Chinese manufacturers. And there are rebates and incentives locally for all electric heat pump setups. And so I can actually offer a pretty competitive quotes to my customers. And like I will outbid people that are putting in American furnace and ACs with an all electric heat pump system. And so it is a really great positioning for me as a business to say I can get you a better solution that's cleaner, it's better for your air quality, all of that, and it's like it's cheaper, like it's a win-win. But I think it will take time for the whole market to transform and like everyone to think along the same lines.
yeah, and it's also you got this whole safety aspect. I mean, it might even been you that sort of mentioned it, but obviously I've been around this. Well, when you've got a furnace, you've got a flue. You've got to get rid of them products of combustion safely. And sometimes flues deteriorate. So you've got a furnace down in your bedroom, and however it gets flued. I mean, obviously every home's differently, but you might
Yeah,
have a situation where the flue is going through a little bit of the house, and
yeah,
often it doesn't get checked. So you've got these old furnaces out in America that the products of combustion, if it's not combusting properly, you've got some really horrible carbon monoxides getting into people's home when you can actually just get rid of the furnace, just put a proper heat pump in.
yeah. I mean, I can speak to this personally. Like when we switched out the furnace in our apartment with heat pumps, and when the technicians were down there decommissioning the old furnace, they were like, "Look, the flue is completely rotted out. Like it was fully rusted out." And so it had been dumping flue gas into the crawl space of my home for years. And so there's probably been like passive carbon monoxide just
Yep.
like sitting in my house. And I I'm confident that there are thousands of homes,
Yeah.
like probably hundreds of thousands of homes around the US that are you're poisoning yourself.
Yeah, yeah. No, I
Yeah.
can imagine. Now, obviously,
Yeah.
where you live is California. Lots of sun. I've
Yeah.
been told. I've never been out there. So are people having solar batteries and sort of getting that? You're having the whole sort of caboodle and using that to sort of power their heat pumps. Is that a thing?
Yeah, California has traditionally been a leader in rooftop solar. And so a lot of homeowners here have rooftop solar. They have the batteries to kind of trend like cover the nighttime when they have less solar production. There have historically been a lot of incentives to push heat pumps, push solar as well. And so for a lot of homes, it's just purely on economics. It makes sense to get solar. I think just a lot of technically minded people here too that love it from the technology standpoint. So yeah, it definitely helps and it helps make a heat pump a little more of a no-brainer if someone's got excess solar capacity and they're producing all of this electricity but not using it and
Yeah.
great. Like let me move the biggest energy consumer in your house onto your solar panels. Like
Yeah.
that's a
Yeah.
good selling point.
Yeah, I imagine because, like you said, I mean, gas is cheaper, but because you've got so much sun,
Yeah.
that must be a great selling point. Now, the other thing I want to make sure I end on good notes for my American friends. Tools. You guys are great at making tools. Snap on. Obviously, I'm going back to sort of the
Yeah.
days when I used to repair my own sort of motorbikey stuff. But yeah, tools. What sort of tools do you? tools have always fascinated me. So they become a little bit like fashion. So like Levi's obviously became a thing way back in the day, didn't they? And all this, and
Yep.
you get the same. So when I was on site, you didn't really have battery operated tools. Well, they were starting to come in very slowly. I mean, Black and Decker used to be a name. I'm going
Yeah.
right back, and then DeWalt, a famous American brand, came into play, and
Yep.
everyone was buying DeWalt. And then that kind of I think Makita then overtook that as the sort of the next fashiony brand. That's been taken over by another American brand, Milwaukee.
Yep.
Um, so for someone that's used lots of tools in my life, I'm just quite interested. What are the sort of tools people use that you guys use? And
Yeah, I mean, there's a lot of Milwaukee. Like,
yeah,
I see that a lot on the job sites, but I think this is one of those Ford versus Chevy type
yeah,
things where like everyone's got their very strong personal preferences. So I see a lot of Milwaukee, I see a lot of DeWalt, and then there's also a lot of like specialty HVAC tool companies too. Like Field Piece makes some really great gauges. Like there's Hillmore, which makes a lot of HVAC specific tools. There's I'm really excited by there's I'm blanking on the name right now, but there's this company Navac. Navac makes these really cool automated flare tools. You just like put the pipe in, you press a button, and it'll make a flare for you. They have like battery powered benders as well, and so it's I think there's every time like when I went to that trade show, you turn every corner and there's like someone's got a demo for every little piece of the installation. You have like a specialty tool. So yeah.
yeah. You're so right. That whole thing of like Ford versus Chevy, it's a bit like that. It's a bit like train versus carrier, is it?
Yeah,
In
yeah.
Australia with cars, it's Ford versus Holden.
Right.
Holden is Vauxhall in our sort of part of the world. But yeah, you always get that, don't you? Do you get involved in training? Because obviously you're doing good work. You obviously understand the science of it. Do you get involved in helping people? Well, you did mention it a little bit earlier about one of the programs, didn't you?
Yeah, yeah. So, um, I think I spend most of my time on customer education, and so I do a lot of writing through my heat pump newsletter
Right.
about like trying to dumb down a lot of these concepts and get the point across that like, look, this isn't complicated. This makes sense for your home. You should do this. And I think I spend most of my time there, but I also I find that I kind of accidentally end up training a lot of the technicians I work with too. It's I think I I think one of my strengths is that I'm a pretty fast learner and I can read an instruction manual very quickly. And so that's the things that I find even the most skilled technicians struggle with is often the controls. And so a lot of times it's like, how do we wire up this thermostat? How do we configure it so that it like works properly? How are we like how do we set up the reversing valve on it so it kicks on the right way in heating or cooling? Like a lot of that stuff I end up end up doing a lot of teaching, but it's definitely something I really enjoy doing. I think there's a lot of people I get excited because I meet more people every single day that want to get into the trade that are excited about it, and I think there's a lot of opportunity to teach them. Yeah.
Yeah, definitely. What did you do? What did you actually specifically do at university when you studied?
Yeah, so my degree's in mechanical engineering,
Right.
so a
Oh,
lot of heat
yeah.
transfer, thermodynamics, all of that. But honestly, I spent most of my time building a race car. I was in this college team called Formula SAE, and so you build a Formula One style race car powered by a motorcycle engine and race it against other schools. And so I spent more time in that shop building that race car and than I did in class, I think.
Do you follow Formula One? Do
I do on and off.
Yeah.
I've been a little spotty, but yeah, I love watching it. It's a lot of personalities too.
So I grew up very close to Lotus. So I used to work
Uh-huh.
at Lotus at one point. I don't even remember Lotus cars. They're actually
Yeah.
building a hypercar at the moment, which is 2,000 horsepower
Yeah.
electric car. My friend's R&D there. He's been an R&D engineer there, well, over 40 years. He's one of my best friends. We grew up in the same village together. But he's the guy that flew over with the Lotus for, I don't know if you ever remember the film Pretty Woman with Richard Gere and Julia
Yeah.
Roberts. Well, in that film is a Lotus, and he flew over with that Lotus. They prepped it for that film, but it was very, very interesting because the scene that Lotus is involved in is a scene because obviously you guys are very used. Well, you're not used to sort of the gear sticks that we have over in our cars. So, so the actual scene involves, I think, Richard and Julia Roberts. Not it's stalling and starting and stalling and starting because they're not used to that gear stick. So he said it was very
Right.
interesting because that's what they're supposed to do. But yeah, he went over there to sort of make sure they knew how to drive it. So I I grew up near that race, that test track, and that Lotus had been involved in all sorts of fascinating stuff. And he used to be allowed to drive at home, and we'd all go to the pub in these fancy cars. But apart from that, I know very little about cars. But so that's just before we go. Then tell people your newsletter. So, like my audience, if they want to sort of get a good insight into what's going on in that lovely country you guys live in, your newsletter called?
Yeah, so I write a newsletter called Heat Pumped, Pumped, and you can find that at heatpumped.org. And it is very American centric, but we talk about the challenges of getting more heat pumps in American homes, a lot of the things around the economics, the policy, the incentives, like homeowner perspectives. I really try and boil down my views as someone on the front lines working with the homeowners and the technicians and try to use that to educate more people about how we can get more of these systems in American homes. And occasionally I'll bring on other experts who are in the industry who will make some guest posts as well. And so, yeah, would love to have you follow along.
Oh, brilliant! Yeah, it's because I think we can look. Our countries can learn from each other. Well, we've always learned from each other.
Yeah.
Which is one of the great things about that connection. Fascinating, fascinating. I've loved it because, like I say, I've got a great connection with America, and I love seeing what's going on. I was over there for Christmas, so I took my 12-year-old daughter over to New York for Christmas because I've spent a lot of time in New York
Yeah.
in the '90s, so it was nice to show her around. And I didn't show her all the old haunts I used to go to because obviously I lived there in the hedonistic '90s. It's a bit of a different place back then. Thank you ever so much for coming on the show. I really, really appreciate it. Thank you ever so much.
Yeah, likewise. Thanks for having me, Nathan.
Pleasure.